Hey everyone. Today I thought we'd talk a bit about this multi-dataset functionality. So this was a feature that recently appeared in HDF5 1.14.0. And what it does, it lets you, in one call, write or read from multiple datasets with multiple selections. And I think Scott, Lori, is that right, gave a talk on this. And it's mainly used in HPC applications. So there's a link to the RFC for this feature. I put in the chat. And I think it's implemented for the standard HDF5 library, except that it defaults to kind of a sequential implementation. I.e., if you call, H5D write multi with 10 data sets, it'll write those 10 selections one after another. So no real different than if you had like a for loop and did it yourself. But this opened up an interesting possibility for the library combined with the RESTful combined with HSDS. For a long time, there's been this conundrum with HDF5 API and HSDS in that HSDS enables multi-processing, right? It's a highly scalable data service. So you can have many requests being processed simultaneously. The challenge, though, is that with the standard HDF5 API, everything's sequential, right? You can, if you want to read an attribute, you read that attribute. Then you want to read another attribute, you read another attribute. And the problem with that, with client-server-based applications, and especially client-server using cloud storage, is that the latency in each of these steps builds up. So if you can do things in parallel, that can greatly speed up the performance. Whereas if you do the same operations with the library and a local POSIX file, you're not going to get much of an increase because you're not gated really on the I/O as much. Okay, so Matt recently worked on implementing this feature in the RESTful. And so what it does is it takes these H5D read multi, write multi, and pipes it to the RESTful, and from there sends it to HSDS. So this enables the C applications using the RESTful to do things potentially much faster than they would sequentially, and without doing anything like MPI and such on the desktop. So Matt, do you want to talk about what you did and the benchmark and what kind of performance results we got?
Sure. So like John mentioned, sort of the central insight is that when you're making requests to an external server, the vast majority of your time is just waiting. And so using the RESTful communicates with HSDS through curl. And so using a curl multi-handle, instead of having to, make a request, wait, make a request, wait, it can, with the information from the read and write multi calls, set up all of its requests at once, send them all off to HSDS, and then just wait for all of them to complete at once. And so it's not actually full parallelism, it's just asynchronous, but even with that, it's doing pretty well. So the benchmark we're using, I think it was linked in chat, is based on this data from the ICESat-2 satellite, which I think stands for ICE, write it down, Ice Cloud and Land Elevation Satellite. And so that benchmark is essentially making a bunch of read and write requests based on, how users of the RESTful were having their access patterns be, and just rewriting that to not changing any of its logic besides the read and write accesses, just reworking them from a simple for loop to using read and write multi. Sped that up by about 100%. It went from like 30 some seconds normally to about 16 with read and write multi. So pretty substantial just for rearranging how requests are done.
Right. And I guess we should say that this won't fit every possible application, right? But a lot of applications, you're doing the same kind of processing on multiple data sets. And if that's the pattern of your code, there's potential to speed things up a lot. So these ISAT2 files, they're actually created from an NASA satellite, and there's like multiple ground tracks. It's observing at any given time. So we can say process these 9 ground tracks simultaneously because the structure of each of the data sets for each of these ground tracks is similar. So we're doing the same code just in multiple H5 paths at the same time. So any questions or observations about this?
Oh, sorry to contradict you, John, but I don't believe I don't believe it's necessary for the accesses within each data set to be similar, because you can specify, your own data set, your own data space for each. So as long as every read and write is on a different data set, you can essentially do whatever you want, although each request is only as fast as it itself is going to be.
Right. You'll be gated by the slowest selection among the data sets you have. Yeah, no, what I meant was that if your code, is somehow inherently sequential, like you have to read the first selection to do the second selection, to do the third selection, then the H5D read write multi wouldn't be particularly helpful.
Right.
Okay. So Matt, anything else you want to say about this? I was going to show some Python analog next. That's okay.
Go ahead.
Yep. Okay, let me share my screen. So given the success with C, I was wondering what makes sense in the Python world, right? So usually for Python HDF5, we're talking about the H5 package. And I know Alexander has given talks on H5 a lot in other college doctors. And the typical pattern as new features are added to H5 library is that first, what's called a low-level interface is added to H5 to connect to these new library functions. And then over time, there's maybe a high-level interface, which makes like a more Pythonic way of communicating with HDF5 is added. So I'm doing this a little bit backward. I'm having H5 code that does the high-level interface, and rather than talking to the library, I'm going to be talking directly to HSDS using H5 but still, this should be fine. And I think eventually we could have a H5 analog to this that works the same way, but it would talk with the library using the H5D read multi. But again, if the implementation of the library is not taking advantage of parallelism, there's not really much gain by using that function. Okay, so to start with, I wrote this class called Multi-Manager. And the idea is to have an easy way to manage multiple things and do multiple actions on those things without making the code very obtuse, right? So let me show you how it works. So we start with here, we open a file. We call it mmtest. And then I call this function mmtestf. So once I'm here, I instantiate this multi-manager class. And it has a count, which will become clear later, of 1. Then I can do things like create these groups, G1, G2, G3. So normally you'd have a loop, right? You say, for group names G1, G2, G3, call create group with group name. Here, I can do mm.createGroups, and it will create all three of these groups in one call. Now, this is just, a first iteration, and it actually isn't doing it in parallel. But the idea is that if you had, say, 100 groups to create, those 100 groups would be created by 100 simultaneous requests to HSDS. And you avoid of this kind of loop of calling create group, which makes an HTTP request that goes to HSDS, comes back, and then you make another request, which that latency again would add up. Okay, so now we say our MM2, so I assign MM2 to the output of create groups, and MM2 count is 3. So there's 3 objects it's managing, where in our initial one, there's only 1 object, which was the root group. And if I say mm2.names, I'll get back these 3 paths, the G1, G2, G3. Okay, so let's continue. If I say mm2.createGroup, so just 1 group this time, it will create a subgroup called GRP, but it will create that subgroup in each of the 3 previous groups, i.e., we still have a count of 3, but now our names are G1 group, G2 group, G3 group, and so on. So now I'll do a multi-manager with MM2 and group, and have these, and I can create, this is a little wonky. I can say I have 3 things I'm managing, and I say create groups with 3 paths, and I create these groups /G1/group A /G2/group B /G3/group C. Right? So whereas here, I kind of broadcast this group name to all of the paths. Here, I'm one-to-one assigning. For this first item in the path, I added A. For this item, I added B. For this item, I added C, and so on. Okay, so that's groups and creating groups. Similarly for attributes, so I have an attribute name of A1 and an attribute value of 42. I can say MM4 set attributes, attribute names, attribute values. And for each of these 3 objects, it will create an attribute called A1 with a value of 42. So in this case, it would be attribute A1 of subgroup A, subgroup B, subgroup C. And similarly, I can have 3 attribute names and 3 attribute values, and do MM4 set attributes and set those 3 distinct attribute names, attribute values to the 3 distinct groups I'm managing. Okay. For data sets, we can also create multiple data sets at the same time. So here I have 3 dataset paths. I can say create datasets, and we'll create these datasets /G1 dset1 /G2 dset2 /G3 dset3. Okay, so till now, none of this really has an analog to the H5D read multi, write multi. This is just this little extra special thing you get for talking HSDS. But now this is more directly analogous to the H5D read and write multi. I had 3 selections. I'm managing 3 dataset paths. I have 3 arrays. Okay, so this NumPy A range 0 to 10 creates a list from 0 to 10. NumPy A range 2 to 10 creates a list from 2 to 10. And NumPy A range 4 to 10 creates a list from 4 to 10. And now I do MM2 write selections, the selections and the values. So for these data sets, G1 /dset1, G2 dset2, G3 dset3, is going to write these 3 values with these 3 selections. So we're going to be writing 3 different selections to 3 different data sets in one call. Okay, I can read back the data. So here I'm calling MM2 read all, which means it reads all the values for each data set in each path. And I get a set of arrays, it's 3. And it's a little hard to hear because I can't run the program, but it's basically giving you back what to expect, right? It's like 0 through 10 in the first one, and then 0, 1, 2, 3, 4, 5, 8, 0, and then 0, 0, 2, 3, 4, 5, 6, 0, 0, I think. Okay, but that's the code. Like I said, it isn't currently actually doing the simultaneous writing and reading, but I was more curious to see, how usable this was as an interface for Python programmers. So it's kind of been helpful to write those and play around and imagine how people would use this to speed up things through multiprocessing. Okay, so that's the end of that spiel. Any questions on that? Am I actually talking to you? All right. So, so no questions on read, write, multi. I'll open the floor to questions or comments about anything.
One thing I wanted to ask about was with sort of the multi-manager you did in Python, did you do any sort of like time testing with that or performance testing?
Well, it wouldn't be much point because, like I said, it's not actually doing parallel operations yet.
I see.
Right. So I wanted to kind of get a feel for the user interface aspect, if you can imagine.
So H5Py doesn't expose read or write multi yet?
No. And I think what I've heard in the grapevine is there's not much interest in it because, given that most H5Py users are using the non-parallel version of the library, they wouldn't get any speed up by using it.
That's interesting, because at least for the RESTfuls implementation, I'm pretty sure that it doesn't matter whether you're using the parallel version of the library or not, because, like I said, it just uses some async stuff. So that's interesting.
Right. And I should say, and I'm not adverse to different parallel toolkits, like MPI or Dask is very popular in the Python world. Those are very useful, but I thought there'd be utility in having a way to do parallel processing that didn't require any kind of advanced setup or new components, or managing asynchronous processing directly. The flavor of this is to give people the ability in a sequential program to do parallel operations without, say, if I change this to a using async API, for one, for people who are not familiar with async, there'd be a learning curve to that. And 2, it would require fairly substantial modifications to the programming logic. And I think the advantage, both in that C benchmark we have and in this multi-manager class, is that you kind of can keep your familiar serial implementations, but get the benefits of parallel processing. Right. And one other thing, Matt, is, I think something that the H5D read write multi don't really address in the benchmark, which may be taking up more time now that you've reduced the time spent reading and writing data sets is the non-dataset selection operations. So if in the benchmark, we had to read 10 attributes, that is 10 sequential requests to read those attributes. So if you could have a, HDF5 API way to say, read these 10 attributes at once, that would be a potential speed up. Right, but I don't think that is part of the HDF API at present.
I don't believe it is. Does the ISAT benchmark do a lot of reading from many different attributes?
There are several attributes that are read. So, yeah, so it'll be interesting. One thing I was going to suggest for the seed benchmark is to try to get a feel for which pieces of the code are taking the most time. So it's like a kind of a truism of optimization, is that you don't just take any piece of code and say, hey, let's make that faster somehow. You want to find the slowest segment of code logic and improve the performance of that first. Because improving the performance of a piece of code that only accounts for 5% of the runtime can't give you that much of a speed up, right? But if you have like a 20% of the code that's accounting for 8% of the runtime, that's where you'll get the most improvement for the effort in optimization. All righty. So again, any other questions?
Yes, John, I had a question just on the limits, or what there are the bounds on the data set and the attribute count when you're giving it to read and write multi. And I'm considering here from the RESTful perspective. Do we have any guidelines on how big multi can be?
Right. Well, let me speculate, and then maybe Matt, you can offer your thoughts. HSDS has a limit in terms of the number of requests that can be processed at any given time per node, right? So let's say, and I think that's the limit's 100. So if you have running a 4-node HSDS, meaning you have, like, say, a 4-core server and you're running 1 node on each core, that's 400 simultaneous HTTP requests that HSDS can process any one time. So if the read multi was doing more than that, the effect is at some point, the server will give back this 503 error. So 503 is an error code that says, hey, I'm too busy, please slow down what you're doing. And Matt, I think you ran into some of these 503s early on. So I think now we do have logic in the RESTful that when it gets these 503s, it pulls back, basically does a sleep for that loop to let the server kind of catch up to the processing. The other thing you do is actually just run the server on more nodes. So then you'd have more, capacity to handle more traffic at one time.
Yeah. Right. To talk about from the RESTful side, John mentioned that HSDS has that task limit. And so based on that, the RESTful limits number of active curl requests at once to, I think, 25. And as far as in my testing, I found that it worked well, or worked fine for up to, say, 10,000 data sets at once, writing some hundreds of megabytes to each. So at least in my testing, it was pretty robust.
Okay.
That's good. So in this case, Matt, you are hitting that limit and getting 503s, and then scaling back the number of simultaneous requests you have in flight.
At the moment, number of simultaneous requests is just capped at 25, although the
Mhm.
sort of request back off logic should allow it to work fine if that's a little too high.
Mhm.
And that's
Right.
based on just the HSDS default.
Mhm.
Does the RESTful communicate with HSDS to find out how many nodes are running? So where it might hit a rate limiter in terms of the number of requests that John talked about, does it communicate that information back and forth so you could adjust that that parameter in the async part of curl?
There is a request that returns the number of nodes. If you ever run this hsinfo command, it'll tell you how many nodes are running. And that's just a REST request that returns that data. But I wonder, it might actually be better to not rely on that, but instead rely on the actual behavior, if you will, of the responses. Because, for example, let's say you hard code that in, or let's say you ask the server how many nodes are you, and then your logic is based upon that, and then some other client starts up, and it's directing requests to that same server. Now you're sharing that capacity with two clients, right? And you don't know, beforehand that you're going to have 2 or 3 or 10 clients. So I think it makes more sense just to, try to do as much as you can, and then the server will let you know once you're hitting these capacity limits.
Yes, or in the initial going, you would only get a best case scenario because you wouldn't know what the load was on the HSDS servers.
Right, right.
Yes. But the ability to switch to this async mode from a RESTful as compared to POSIX, that seems to me that's a huge win to be able to do that when you compare it. If you're deciding whether to put it on a POSIX or maybe transfer it from HSDS onto a POSIX side of things, the ability to do these reads and writes async, that seems very significant.
Right, right. Yeah, I don't know how much possible improvement you'd have just with the native library,
Right.
in H5D read multi, especially if you're on a rotating disk, because if you're doing, let's say, 10 simultaneous write operations, then each of those 10 would wait at the seek pointer of the drive to get to where it's going. So that's probably going to bottleneck you right there. The advantage of S3, even though it is relatively high latency compared to a POSIX drive, especially SSD, is that it scales up, right? You can have up to, I think it's 3,500 simultaneous requests on a given S3 bucket at one time, right? So Amazon's done the work to kind of spread out these writes across multiple server nodes in their storage setup. So you get, potentially really high bandwidth, at least high in the non-super expensive HPC world, the commodity hardware world. It's pretty good performance. So anyway, so I'm really excited about this. I think it'll be interesting to see, what kind of limits we can get, and there's always some bottleneck, right? So if you push here, something will push out there. There's always gonna be something that's going to slow you down, right? Whether it's just network bandwidth or CPU. It'd just be interesting to kind of investigate this and find out where the limits are.
Yes, and just to clarify, on the RESTful side of things, it read and write multi works with S3 as well as HSDS. It doesn't make any difference which one you're going to, as far as the standpoint of getting the async performance. Correct?
The RESTful always expects to communicate with HSDS, but HSDS can have, a variety of different things on its back end.
Right. So we have speculated about and I'm not sure it'd be the rest vol or it's a whole new vol, but something that wrote and read directly from S3, right? And that would have the advantage of not requiring a separate HSDS server to be set up.
Okay, thank you for the clarification. Okay, I see that, but so read and write multi do not currently have a pathway to S3 storage,
Except through HSDS.
except through HSDS. Yes.
Now, for read operations, there is a possibility of having something similar to what Matt did in the RESTful for the ROS3 VFD.
Yes.
Because the
For read
ROS3
only.
is also doing curl requests, right? If you could have async curls, right, that's going to help speed things up.
But in terms of the read only S3, read and write multi don't work on that at the moment.
Well, write multi doesn't work because
Right. Yeah, that's true. Yes.
it's a read only. Right?
It would.
The read multi should work, but it's going to boil down to a series of sequential selections over the data sets. So the performance would be the same as if you had a for loop versus using H5D read multi.
Okay. Okay. All right.
Right. Well, if there's nothing else, I thank everyone for their time, for the interesting discussion, and we'll rejoin next week.
All right. Thank you, John. Thanks, everyone.
Thanks, Lori. All right. Bye-bye, guys.